All right, let's finish off this review. So, talking about factoring, factor each expression completely. Recall you're going to always start with the greatest common factor, see if you can find one of those, and then you're just backwards foiling. So I'm going to work through this, just a couple of them, and make sure that we remember how to do this so that we can plow forward. So looking at number 18, again, looking for a greatest common factor, there's nothing that divides out of all three terms. There's no number greater than 1 out front, which means that we know that this is just going to be x times x. And again, we look for things that multiply to negative 36 and have a difference, because it's a negative 36, of 5. So if we look at that, that would be something like 1 and 36, right? Don't have a difference of 5. Those do not subtract to 5. 12 and 3, those subtract to 9. Don't work. 9 and 4, absolutely it does. So negative 9 plus 4 gives us that negative 5 that we want. So we put in negative 9 and a positive 4. So we're looking for pieces that multiply there. So just backwards foiling. Again, I'm just going to move down the left side. Number 20, again, looking for a greatest common factor. Notice that here, if I'm looking for something that divides out of both of those, they definitely are both divisible by 4. And they both have a v in common. So we're going to pull out a 4 and a v for backwards distributing. So in this case, 8 divided by 4 is 2, right? V squared divided by v, that's just 1v of those left. 20 divided by 4 for the next term is 5, and the v's cancel. So in this case, you're just left with 4v, 2v plus 5. All right, so moving down, number 22, we've got 15b squared minus 20b minus 75. So again, we always look for something that divides out of everything first. In this case, we've got 15b squared, right? That's divisible by 5. 20 is divisible by 5, so is 75. So we're going to pull the 5 out front. If we divide that out, we get 3b squared minus 4b minus 15. Notice this one, again, you're going to backwards foil. However, you've got the 3 out front right here. So the 5 is just going to come along. We know that the 5 in the end is just going to be out front. This 3, however, is going to affect things. So in order to get 3b squared, we know it's going to be 3b times b. That's the only thing that will multiply to give me 3b squared as whole number coefficients. Then looking at our last term, right, negative 15, the only thing that really is going to multiply to that is 3 and 5. One of them needs to be negative, or a 1 and 15. So I'm going to try this one first. And remember, we're matching them up so that we find something that will give us this negative 4 on the inside. So again, if I match up this right here, that would give me like 15b. This right here would give me 3b. Notice if I subtract those, if one of those was negative, that's going to give me 12b, not negative 4b. So I'm going to try something else. I'm going to maybe match the 3's together. So that would give me 9b. B times 5 is 5b. Notice that if this was a negative 9b, that would allow me to have negative 9b plus 5, and I get that negative 4 that I'm looking for. So in this case, I know that I'm going to have 3b and b in the front, right? Those were my two front pieces. And then I know that I want the b to multiply by the 5, and I want the 3b to multiply by the 3. So if I want the 3b to multiply by the other 3, I need to put it over here in the other parenthesis, and that means the 5 gets to go here. And we wanted the 9, right, this piece, when we multiply, to be the negative value and this to be the positive. Then again, we talked about just make sure, like, it never hurts to go back and just make sure that it all worked. So if I was just checking this really quick, I would say, okay, well, that's 5b when I multiply the inside pieces, and the outside pieces are 9b. So that will give me, negative 9b. That gives me that negative 4b in the middle. If they don't work out, then you got to go back and try something else there. Okay? That would be the factored form of that piece there. All right, let's do 2 more of these. So 24, again, simplifying there. Looks like we've got things that are divisible by 3. So we pull the 3 out front. We get 7p squared, 2p minus 9. Notice again, you've got the 7 right here. So we know that that's going to be 7p times p. On the end here, we're going to have 9, so we need like 3 and 3, or 1 and 9. I usually start with the less drastic ones first. I don't know why. Okay, so if we look at these ones, notice we could get 3, and we could get 21p. Yikes, that does not subtract to 2. So, not that one. We could, now that's 3 and 3, so even if I switch those, that guy doesn't look like he's going to work. So instead, we should do the 1 and 9. See, I should have tried this one first. So if I do the p times 1, 7 times 9 is 63. That's way too big. So what if we match the p with 9, 7 with 1? That works great, right? 9p and 7p. If one of them has to be negative, that looks perfect. So we're going to go 3, and in the front, we're going to put these two pieces. So 7p and p. We want the p to multiply by the 9, so we put them in the other parenthesis, and we want the 7p to multiply by the 1, so we're using that 9 and 1. And we want the 9, the larger value, to be positive, and then the negative 1. Again, you can check that if you'd like to by multiplying those. Alright, last one I'm going to do in this section is just 25. Remember, this is a difference of squares, so if you ever find something difference, meaning there's subtraction, right? And these have nice little square roots. We just use the square roots there. We know that this is going to be 3x and 3x, and we know that this will be 4 and 4, and they need to have different signs so that that middle term adds to 0, given that there's no middle term seen. So we have 3x, 3x, 4 and 4, and then we know that one's positive and one's negative. Okay, so just remember that guy is a difference of squares. Cool. Okay, we're almost there. So just a reminder, I'm going to do one of each of these to go through complex numbers and graphing the quadratic inequality. So for each complex number, graph the number and then determine its modulus. So remember, we've got a real axis and an imaginary axis when we're graphing complex numbers. You have a real part and you have an imaginary part, so it works like a coordinate point. We go 1 in the real direction because it's positive, and then we're going to go up 5 because it's positive. Oh, I wrote that right there. Maybe I'll do that black. So that point right there is the graphed complex number. You're done with part A. Part B says find the modulus, or the length. Now remember, length of a complex number, we can either use distance formula or the Pythagorean theorem in a way. And you say, why? Well, the length, and you don't need to draw this part on your paper, but it's just its distance from the origin. So pretend that's a straight line. If I'm finding that distance, I could think about it like a right triangle, and I'm really using the Pythagorean theorem. So I'm saying it went 1 this way, it went 5 this way. So I have like 1 squared plus 5 squared, right, equals that diagonal squared. And so we just take the square root of that. So the length of the complex number, and we always wrote it with this little absolute value bars because they mean length, would be like the square root of 1 squared plus 5 squared, so this piece right here. And if we simplify that, 1 squared is just 1 plus 25, so it looks like the length of this complex number would be the square root of 26. Okay. All right, jumping down, 28, the graph, or graphing each inequality. This first one, notice it's in vertex form. The second one is not, so you do need to find the vertex on the second one. The biggest thing on this one is make sure you recognize this one would be dashed, right? And then you need to shade appropriately. This one would be solid because it includes. So maybe let's look at 29, just because we need to find the vertex. So I'll remind you how we do that quickly. This is in standard form. So if I want to find the vertex, to find the x value of the vertex, I do negative b over 2a, right, where b is my middle coefficient. So I'm going to do negative 4 over 2 times the a value, which is 2. So this is equal to negative 4 over 4, which is equal to -1. So my x value of the vertex is at -1. And then if we know an x value, we can just plug it in to find the y value. So I take my original equation and I just put -1 in wherever there's an x. So that gives me 2 times 1. 4 times -1 is -4 minus 1. So in this case, I'm going to be left with -3. So that's my y value there. So I'm going to come over here on the graph, -1 down 3, and this is where my vertex is going to be. And then we're just going to use this guy, right, like we did on our parabolas. It's stretched by 2. So remember, when you go 1 unit away, it usually goes up by 1, because 1 squared is 1. We're going to double that, so we're going to go up by 2. 2 units away from the vertex, so over here, usually goes up by 4, because 2 squared is 4. But because we're doubling that, we're going to go up by 8. So we're going to be clear up here. And that's as far as we can go there. Now again, this one's solid, so just do the best you can. Let's see if we can draw a parabola here. Okay. Not too bad. Oh man, that's close. And then we just need to shade. So again, we look at this. This says y is greater than. Remember, we talked about greater than means above. And in this case, above, if I try to shade on the outside, it'll eventually drop below. So that's not where we want to shade. We want to shade above the function. So above does not necessarily mean inside. Sometimes it's on the outside.